Alright, boys and girls, welcome back to the drive-thru for a 4 mix. This is ridiculous. This is the 4th attempt at making this video. You know, I could be mad, but the only person I could be mad at is myself, because this is what I failed to learn in life, and now it's my task to teach it to you guys, so I'm going to get it right this time. Here we go. So, it's not that it's completely difficult. It's that there are many places where I can make a mistake, and if you make a mistake, obviously you know in algebra it's going to lead you to the wrong answer at the end. So what do we need to know in order how to do this? What does it mean to have an inverse operation? You know this. You got operations, and then you have their inverses. Well, their inverses essentially undo whatever that operation did. So what was the inverse of addition? It was subtraction. What was the inverse of subtraction? It was addition. What was the inverse of squaring something? Square rooting something. What was the inverse of taking the cosine of something? Taking the cosine inverse of something. Well, now, if you have something multiplying by a matrix, the inverse of multiplying by a matrix, there is no dividing by a matrix. So the only thing you can do is multiply by the inverse of the matrix. So that's the first thing you need to know. The inverse operation to multiplying by an inverse is multiplying by its inverse. However, you need to make sure you multiply it on the same side of the inverse, because as you might remember from earlier, that multiplying inverse, the order matters, or it is not commutative. How do you find the inverse of a matrix? Well, that's from last chapter, but if A is some matrix X, Y, Z, A, and then the determinant of A is equal to XA minus YZ, then just as a reminder, A inverse, what you do is you switch the corners. So A goes here, X go here. You do the opposite sign to these and leave them where they are, but you have to multiply it by 1 over the determinant. Okay? We're also going to show you how to use your calculator for some of this, especially the 3x3 stuff. Okay, here we go. Number 2, we are going to do 2 different ways. Number 2 from your homework. I'm not doing number 1 because the answers are really nasty. So if you go back and do number 1 and you get weird answers, don't be surprised. What do we have going on here in number 2? Well, we have a 2x2 matrix multiplying by something, x, and the answer is a 2x1 matrix. So the question is, what in the heck is x? What might x be? How do we take 2x2, we multiply it by something, and we get a 2x1? Well, if you remember, in order to multiply a 2x2 by another matrix, these inside numbers had to match up. And if you remember, the outside numbers give you the results of the answer. So that means we are multiplying it by some 2x1 matrix. Something that looks like that. So let's set up, I guess, what we might consider an equation, because it does have an equal sign. 3, 1, negative 9, negative 6 times a 2x1, so we'll call it A and B because we have no idea what this matrix is, and the answer is 12, 0. I have no idea how to do this. That's okay, just do one step at a time. Row by column. Excuse me, I totally screwed that up. Row by column. So 3A minus 9B equals 12. That's the answer to that. We know that. Row by column. 1A minus 6B equals 0. Okay? Well, I think what we would probably normally do is multiply this thing by like 3 or negative 3. Multiply this thing by negative 3. And so you get negative 3a plus 18b equals 0. Below that, we'll rewrite that one. We're just doing elimination method here. Hopefully you guys are familiar with this. You might not be totally, you might need to be refreshed, but hopefully you know how to solve a system of equations. We are adding these things. That gets rid of that. You get 9b equals 12. Divide each side by 9, and you get b is 12/9, which is 4/3. Okay? All right. So, we need to find A. Well, how do we find A? We plug in our number for B. Let's plug it into the top equation. 3 times A minus 9 times 12/9 equals 12. So 3A minus 12 is 12. Add 12 to both sides. 3A is 24. A is 8. So A is 8. Let's get these in order. B is 4/3. That's the answer to this question. A and B look like this, so you would say X, sorry, I'm running out of room. X is, which one's on top? A. 8, it's the 2x1 matrix that looks like that. Now what I want to do is show you a completely different way to do this question using inverse matrices. So let me just state some facts here. What we have here is AX equals B. What we want is X. So what we're going to do is multiply both sides by A inverse. And you can get X is A inverse times B. Okay, so we just need to know A inverse. Well, A inverse is 1 over the determinant of, let's see, -6 and 3 switch. Make that a negative, make that a positive. The determinant is -18 minus a -9. So that's -9. So A inverse is that. So let's rewrite it as -6 over -9. That's a positive 2/3. -1 over -9 is a positive 1/9. 9 divided by -9 is -1, and a -1/3. That is A inverse. How do I find X? X is equal to, it's a 3 there. That times B. Check it out. No. This should be 2/3. Gosh, I caught it. 2/3. Two-thirds of 12. So we're just doing our normal row by column. So it's 8 plus 0 over 1/9 of 12 is 12/9 plus 0. Love it. And you end up getting 8. And look, it's exactly what we got for this, with significantly less work. Not to mention I had to remind you how to do everything. So, from here on out, our strategy is going to be to multiply by the inverse. Okay? Write each equation as a matrix equation. Identify the coefficient matrix, the variable matrix, and the constant matrix. So, here's your remember, we're not even solving these. So there's your coefficient matrix. We're going to multiply it by a 2 by 1. There's your variable matrix. And the answer is your constant matrix. Not to be confused with the crazy hot matrix, which is something everyone should see but never in school. Okay, that's it. That's all we had to do. This is the constant matrix. Okay, let's move on to another one. Solve them. Let's do one more. Let's see. Let's pick number 10 using matrices. So number 10. A is 2, 1, 3, 2 times x, y equals 12, 7. What do I want to do? Well, I need to find A inverse. And that is 1 over, let's see, 4 minus 3. Nice. 1. Love it. Times. Now we have to switch these. Love that. Negate these. So A inverse is just this, because we're multiplying it by 1 over 1. So what would we do? Let's do A times A inverse times X equals A inverse times B. That's going to be gone, and we know that X is going to be this, A inverse times this, B. So it's 2, negative 1, negative 3, 2 times 12, 7, row by column, row by column. 2 times 12 is 24. Negative 3 times 7 is 21. Negative. Negative 1 times 12 is negative 12 plus 14. And I'm just working where I got room so you can see everything. You end up getting 3, 3, 2. The 2 by 1 matrix, 3, 2 is what X equals. Oh, no. Okay, so that's what our big X matrix equals. So in this one, we should get X equals 3, Y equals 2. Let's see if I got it right. 6 plus 6 equals 12. That one works. X equals 3. 3 plus Y is 2. 4 equals 7. And we know we're right. Nice. Now, 15 we're going to do on our calculator, okay? So give me a second. Let me get this set up. Okay, so what we have here is A times X equals B. So to find X, we need to do A inverse times B. We are going to do all of this in our calculator, or at least we're going to try. So let me turn it on. Alright, now, you've never done this before, so you're going to have to practice. I've screwed it up a million times. First, you got to go in, and we're going to edit these. So I'm going to edit number 1, which is A. We want, well, let's list our matrix. A, negative 3, 1, 2, 4, negative 1, 1, negative 1, negative 1, 2. Okay? B is negative 5, negative 8, and 9. Alright. So let's name A. A is a 3, enter, by 3, enter matrix. Okay? Now, we just need to plug in our numbers right. So, -3, enter. It's going right. 4, enter. -1, enter. 1, enter. -1, enter. -1, enter. 2, enter. 1, enter. 2, enter. Let's check it and make sure it's the same that I wrote down. It is. Okay? Now, let's go back to the matrix. I honestly feel like I'm in the matrix sometimes. Let's hit 2. Okay, let's go back to the matrix. Let's edit it, and we want to edit number 2. Okay, B is a, let's see, 3 rows, 1 column. So it is a 3 enter by 1 enter. Its entries are -5 enter, -8 enter, 9 enter. Alright, now here's what's wild. You just got to remember that all we want to do is this. We've just done all the hard work. Check this out. Go to quit, and we want to do matrix A. But we don't want A, we want A inverse. So hit that. You see that, what I just hit? I hit the X inverse key. It's nice to have that. And what do we want to do? We want to multiply it by the matrix B. And the answer, X equals -2, Y equals -1, and Z equals 7. Now, if you're that smart kid that was like, this isn't even worth it, I could do that by hand. I challenge you to. Solve that system of equations by hand faster than I did in the calculator. So this is, again, a great use of the graphing calculator, and you can imagine that with this we could solve huge systems of equations. And you know, if you just thought about like how McDonald's makes money, like let's assign A as a variable for cheeseburgers, B is a variable for McDoubles, C is a variable for fillet of fish, D is your fries. Just think about how many variables they have, and they're trying to run scenarios to how to maximize their profit, and that's how you're going to come up with these humongous systems of equations that you're going to need technology to help you solve. Oh, 4th time's a charm. Boom!